Hello, it's Duncan. We're at a nice stage with the Gilded Rose software at the moment. We are delivering value to our customer, keep on adding features, and the software is stable. We're carrying a little bit of technical debt. There's always things that might be better, things that we'll sort out over time. But in general, we are, as a development team, really quite happy, and our customer is quite happy. It's a lovely place to be. So our customer has asked to sell another type of magical good, and this is Backstage Passes. And she's written a story. It's here in our document. It says, Backstage Passes increase in value until sell by, then worthless. And we've had a little chat about what she means by this. And we've come up with this detailed statement, and it is that the quality increases by 2 when there are 10 days or less. And that's to go until the sell by date. And 3 when there are 5 days by less. But after the concert, I guess after by sell by date strictly, then the quality drops to 0. Nobody wants to buy them. And also the quality is capped at 50. So Bree's quality is capped at 50 and Backstage Passes quality is capped at 50. Now these two statements that 2 of our items have a quality capped at 50 mean that we should have a chat with our customer and decide whether it applies to just Bree and Backstage Passes or whether it applies to every item, and also whether any item can ever have a quality that's greater than 50. So before we go on, in order to understand things a bit better, let's go and have a chat with our customer. And we came up with the following statements about quality, and we've written a story for it. And the story says, no item can ever have a negative quality. That's a hard limit in our system. I think we may have seen that already. I can't remember. No item should have its quality raised above 50 by updating. So in other words, no matter what happens in our algorithm when we update the quality of items, there's a hard bar of 50 for every item, doesn't matter what it is. But we can take items into stock with a quality that's above 50. And if that happens, then they can't go up any higher. And if they go down gradually. They don't just drop to 50. Now that's quite a sort of interesting statement of what quality means. And I think we'll probably want to sleep on it to do this story about Backstage Passes first of all, and then to think about how we can represent quality in our system. But it's going to inform maybe a little what we do. One of the early XP extreme programming practices was sit on your cards, and it meant that don't consider the future when you're implementing a story right now. And that's generally good advice. We shouldn't over-design. But at the same time, if we know something's coming up, and especially if we know that it is a hard requirement about our system, like these quality caps, then there's nothing to stop us at least taking into account as we design our systems. So let's get on and write a test for Backstage Passes, keeping in mind quality caps. So first let's go and find the tests that we've got in this area. And we have these updating tests. And looking down here, you can see we have normal items, and then we've got our special case for aged Bree. Sulfurous is taken care of by normal items with no sell by, which is a bit of an innovation on our part. Now we're having to scroll up and down here, and we're about to make that worse by adding more things. So I think maybe we will duplicate this, split it into normal items and aged Bree, and then add another test class for our Backstage Passes. So we'll make a copy of this file, call it standard updating tests. And I'm always editing the wrong one, so our standard updating tests we want to remove the Bree items from. Like that. And then the other updating tests are now aged Bree updating tests. So we will take out these. And then we'll call that. Right, and then we'll run all our tests just to check. Good. And now this is our aged Bree tests. We can just remove this little string here, I think. Because the context is aged Bree after all. And it's a good trick to pretend that these sentences begin with it. So it increases in quality, it increases in quality, and it doesn't get better than 50. Okay, I think that's good. So let's commit that before we go on, because we haven't changed any production code and we might want to go back to this point. Extract aged brie updating tests. Good. Now there's no shame in copying these again for our Backstage Passes. Gives a framework to go on. So now let's write the behavior for passes, and I think maybe we should just look at one test at a time because we're adding functionality. We'll leave this one as a backstop, and we'll say that all the items here are going to be Backstage Passes. And Backstage Passes increasing quality by 1 every day until 10 days to sell by date. So if we go out 10 days, then we should update by 1. So let's run that. And unsurprisingly it fails, because our Backstage Passes are just at the moment being treated like normal items and they degrade rather than getting better over time. So let's now go and look at item, where all of our updating is happening. Okay, so at the moment we've got update standard and update brie. So monkey see, monkey do, we can just duplicate this and say, what would happen if we had update pass? And we now need to install that somewhere. And we can do it here. So we can change this to a when, which would allow us to put Backstage Pass in here. Now that won't have fixed our test yet because we haven't changed what update pass does. And before we go on, we'll make a note to consider when a Backstage Pass is a Backstage Pass. Is it something that its name is Backstage Pass or begins with Backstage Pass or something like that? So we'll come back to that in a minute. Going back down here though, Backstage Passes improve. We're still going to cope with a null sell by date maybe. But we now need to know how many days there are. Well, in fact, I think we could just remove this for now and we might get the right behavior. Or at least the behavior that our test shows. No, I'm wrong. We went down by 1. Why is that? Having a look at our tests, Backstage Passes. We wrote Backstage Passes. Well, that does kind of prove our point about when is a Backstage Pass a Backstage Pass. So I think we might fix 2 things in one go by making this, by removing the subject from this when. So this is name equals aged brie, but name dot starts with Backstage Pass. Do we want to be case sensitive or insensitive? Let's leave it for now. Okay, so we are now finally running. Let's add ourselves another test. So here, increases by quality by 2 every day until 5 days to sell by date. Was that a requirement? So 2 between 10 and 5 and 3 between 5 and nothing. So we should say every day from 10 to 5 days to sell by date. So at the point where we get to 9, we wish to go up by 2. And we could test the other boundary as well. So it should still be true on 5. Okay, let's run that. Unsurprisingly fails. So let's go back to our item. Now we need to work out how many days there are between 2 local dates. But one of those local dates, the sell by date, might be null. So I think the sensible thing to do is to pull this test out early. So we can say here, if the sell by date and if the sell by date is null, then we know that our behavior is that we don't have any change in quality. So we're just going to return this, the item. That's the equivalent of taking this 0 that we had in here and adding 0 to the quality to leave us with the quality. It's not quite true because of this coerce at most. That might change the behavior, but we still have a story about maximum minimum qualities that will allow us to address that properly, I think. So that's a little get out clause. That will then allow us to say days until sell by. Now what's that? That is on epoch day, to epoch day. So if we take the day that we're on to epoch day, and sell by date is a little bit further on, so we're going to say sell by date to epoch day. So those are both longs. So I think we should end up with a long. Good. And now armed with this, we can say that we don't need this test here. And we can say days until sell by is less than 10. We want an improvement of 2. So let's run that. Good, we're on a roll. Back to the test. Add another one. Increases by 3 every day from 5 days to sell by date. So when we say 5, we mean from 4. So that's going to go to 45. On the sell by date. Well, on the sell by date, I guess we should still have the same behavior because people still might be buying them to get to the concert that evening. There's issues here with things that are really, really time sensitive, which we will skip lightly over. Run that and see it fail, which it does. Back to our item. When it's less than 5, the change is 3. Now we have a problem with ordering because the when will hit this condition before this. So let's pull that out of there and move it up to there. And check that passes. Okay, good. Back to our tests. We have one final one, which is that we call it degrades completely after the sell by date. So what does that mean? It means that if we tried October the 29th plus days 1 and it was 45 or something, then it should just go to 0. And I guess in principle that applies to plus days, any number of plus days. We can show it just with one more. Back to our item. What does this mean? Well, we could create a negative improvement or we could just have a special case for this. And I think probably we should just have a special case, which is to say that we can say in here, if days to sell by is less than 0, then we should return a copy with the quality is 0. Now I don't like these lots of returns, but we're just getting the test passing at the moment. Okay, that's still failing. And now it's our doesn't get better than 50 that's failing, which is interesting because it passed so far. And you can see here, in fact, that this was the test we had for Brie, which got better, but we know this doesn't apply to Backstage Passes. Backstage Passes, if we're going to test them, we should test them not past the sell by date, but maybe on their sell by date. So we should say that if we checked on the sell by date, it would normally go up, but it will be capped at 50. So if it is 50, it stays at 50. And in fact, we could say if it's 49, it will go up by 3, but still be capped by 50. So let's try that. Good, we're all passing. Now, we may not like the code in update pass, but now we're in a position with all the tests in place to refactor mercilessly. I think maybe the best change we can make in isolation is to, instead of having this improvement, have the resulting quality. So this would be 3 plus quality. This would be 2 plus quality. And this would be 1 plus quality. And then that would allow us to move this into here. And have it make the quality 0. We take that out. This is new quality, and then we don't add that. Okay. Now this null here, sell by date, and here is still bugging me. It would be nice to produce a situation where we didn't have to consider that in our items, in our updates. And we can do that with another strategy. So what we could say is that there's a strategy of update undated. And when you don't have a date, we know that we always just return the item as unchanged. So that's a behavior that actually all these things do in that case. And we could install that at the top level. So we could say in here, when sell by date was null, then our updater is update dated. Mess that up, should be update undated. Now, if we run that, it should pass our tests. Good. Now, unfortunately, we can't just remove these tests. Actually, ironically, we can there, and there. But if we try and remove this one, then the compiler knows it would get a null pointer exception here. So we've still got the problem that in the type system, the sell by date is nullable, although in practice at runtime, we think that if we're in any of these methods other than this undated one, then a null sell by date shouldn't get through to us. So what I think that means is that this is a require. It means that it's a precondition of these that we can only test at runtime. So we could say in here, require, not null, our sell by date. And if we're wrong about that, well, we'll get a nice little message. Our program will fail, but we'll get a nice little message to tell us why it failed. So we can remove that. And now in here we can do the same thing. And the nice thing about require not null is that it sets up a contract that tells the compiler that if it got through here, that the value, this sell by date can't be null. And so the flow typing can now set in here. And it knows that this can't be null. The compiler is happy. And our tests are happy, so we're almost happy. Why are we not completely happy? Well, I suppose really it's this problem here that item needs to know about all the subclasses that it could be. What we'd like is some sort of factory of our item. Why are we not completely happy? Well, I suppose it's this updater for, because every time we add another type of item, we're going to have to update this item type. We'd like to be able to separate those concerns. And in order to do this, we're going to have a function that we can call to create an item, where that function is responsible for working out which of these update strategies to use. So let's work our way towards that. So to make a method like updater for static, to move it out of this class, basically we've got to pass everything to it that it's pinching from this. So for example, sell by date. So let's introduce a parameter for the sell by date, and we'll call it sell by date. And now that's being passed in here. But IntelliJ has been a bit overzealous, and we want to make that the sell by date that we've passed in. And the same with the name. So this is name. Again, IntelliJ is doing the wrong thing here, I think, because we actually asked it to extract a parameter. But there we go. Okay, so we'll run that and check that it all passes still. And it does, which is good. But there's another place that we depend on this, and this is here. So we really want to make this item and this item. So this is a reference to the static function and there as well. And one last one. Now the type of updater is not going to be just something that takes a local date, but something whose receiver is an item, takes a local date and returns an item. That's the type of all of these functions down here, these extension functions. So, question, does that pass? It does, and now we think that this might actually be able to be moved to be a top-level function. So let's just cut it and paste it. And run that. Good. Now item is almost divorced from its creation. At the moment, everything that creates an item will be calling this constructor. What we're going to do is we're going to move this updater up into the constructor as one of our data parameters. Now it's a little weird having a function parameter in a data class, and we'll address that later. But for now, let's just check that it actually passes. Good. And finally, we want there to be a function that everything can call to create an item. If we make a function with the same name that takes these parameters, but not that final updater, then that can call our constructor. And it can pass it the name, the sell by date, the quality, and it can call this updater for, providing the value that's in this constructor here. And if we do that, then we can remove this default value. Now, everything that was calling the constructor, we'll find will actually be calling this function. So you can see all these places that create items and now calling our function rather than our constructor. And that's because our constructor doesn't match the parameters that we're passing, because those uses aren't passing an updater. So now we're free to rename this to something like create item, or maybe item of fields idiomatic Kotlin. That will change all of those places to use item of, and that means that we can take this thing and move it down here, and then move all of this code out of our item. Now, where do we want to put it? Well, I think there are two things going on here. One is creation, which is updater for, So let's create ourselves a new Kotlin file, and we'll call it creating. And we're just going to move Updated4 into that. In order to do that, we're going to have to make it public, which is fine for us. So cut that out of there. We could do that with a move refactoring, but it's easier just to do it by hand and fix it up. Now back here, these are all now need to be more visible, but that's fine to us because we don't mind. And now let's take all these and we'll move them out of here. And I was going to say we should put them in a file called updating. It turns out we already have one. So that's handy. You can see updating already has what it means to update a whole list of items. And so we can add into here what it means to update individual items. Now our item is really clean. Oh, actually, no, it isn't, because I messed that up. This item of is the thing that wants to go into creating. And Updated4 wants to go into updating. Should have seen that. And in fact, that means that these could all be private. So let's make that happen again. They just have to be visible to the public Updated4. Now that was quite a bit of work without running the tests, so we will run the tests. And everything passes nicely. So just to recap, we now have item as a data class. There's no subclassing involved. And it has this strategy of how it's updated that is populated by this function here, which creates an item and works out which updater to use. And updating says, okay, well, if I haven't got a sell by date, then I know there's this strategy. If I'm free, I know there's this strategy, and so on. Looking down at those strategies, there's quite a bit of duplication in here. It's a bit of a mess, to be honest with you. I don't like it. But we know we have a story to work on about limiting of quality. So I think we're going to leave this alone for now. Before we go on, I think I'm going to commit that. So this is extract. And really the thing we've extracted is item of. Wouldn't surprise me if there was some unused imports now. Only one warning, it seems. And that is actually an unused parameter, so let's mark that as OK for this function. Sanity check that the test will pass. And try that commit again. Good. Now I promised that we would consider the issues with item being a data class. Now the issue is that data classes have copy methods, and those copy methods can break encapsulation. And in order to see that, let's just edit one of our tests. So we'll edit, say, the age debris updating tests. Now, so these show that the behavior of age debris. And it should really be that if we create an item whose name is age debris, it should act like age debris no matter how we create it. But here's a way to break it. So if we pull this out as a variable, what's it called, item, but instead of starting as age debris, we'll start as a banana. And then we'll copy, changing the name to be age debris. And now we'll run this test. And you can see the issue here is that we have ended up with creating an item in the first place with the default strategy, the one here, the update standard, And then we change the item's name, but that hasn't changed the strategy. Which is a bit of a shame, really. So how do we address that? Well, let's undo that change. The only way really we can solve the problem is to not have item be a data class. So what do we get out of a data class? Well, we get equality, we get hash code, and we get the copy. So let's ask the question, where do we use the copy? If this wasn't a data class, what would break? And you'll see the places we actually call copy are places where we change the quality. But changing the quality shouldn't change the behavior. So it would be safe to add a method called copy, taking just a quality to our item. And that we could implement as returning an item. Now, we could call item of in this case, but we know that we're never going to change the way it behaves, so we can just pass our name and sell by date and the quality that we've been given to update in here. And copy, not necessarily a great name, so I think we might call this with quality. And now we've got the control of the method, we can do that and it will rename it everywhere. So if we go back to the last function, you see now it's calling with quality, which is great. So that should build, except that we do need to pass up data, which I missed. Now that compiles. We're actually only running one test here, it turns out, but even that failed, and it fails because we don't have an equality method now. Now IntelliJ will rescue us, so we can say generate and say that we want equals and hash code. And it's probably true that an item shouldn't look at its updater, that an item is really just defined by its name and sell by date and quality. Actually, it's probably more complicated than that, because what if we had two items in stock, both of which had the same name, the same sell by date, the same quality? Are they the same item? That's complicated, and it's a thing that we haven't really addressed in this code base yet, because we haven't had to ask the question except in tests whether two items are equal. We should probably talk to our customer about whether items have a particular serial number that we could use or something like that. In the meantime, though, let's just crack on with this, say that we want just these three properties to be included in our equals. And the same for hash code. Okay. IntelliJ has generated those for us, and now if we run, and in fact we better run all the tests. Now we pass, and because the only copy method we have is this with quality, then we know that we can't build an item that breaks its local invariance. Is this worth the complication of having to define equality and hash code and keep them up to date? I don't know. I think it would depend on the code base. It would depend on the amount of trust you have. Personally, in other projects, I've tended to go with the data class. And so I think maybe we'll leave it as not a data class now, so I can learn how well that works. It's quite an easy change to reverse, I think. And we're just left with this bit of noise here, but I'm not really happy about that. I think maybe, though, I would use item of in here just to properly express the fact that we always want to go through this item of in order to create new items. Okay, let's run that test. Run all the tests. We're all good, so let's commit that. So, final recap. As part of our work on adding one more item type, we have extracted the code that creates and updates our items. so that now our item doesn't depend on that code. We don't have to update item every time we add a new type. We'll just go along and add different update methods into this file here for the different types of items that we might stock. We're still not entirely happy with it, with the way this is factored, but we're hoping that the next story might sort that out for us. If you want to see that next story, then please subscribe to the channel. I hope you've enjoyed this, and if you have, you could like it, which would encourage me to keep going. Also, if you like this, I think you would like the book that I wrote with that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the description below. Thanks for watching.